Is right now, which is the technical session on how to prepare for the aerospace industry. This session is going to be conducted by Mr. M. Mohanavel. We have him from the aerospace machining. He's an aerospace machining consultant who's joined.
Ladies and gentlemen, good afternoon. So everybody, this is today's my last presentation because we need to fly. Because you know, everybody knows that the more crowd in the airport than the railway station. So the future, you know, all the middle class, most of the middle class people are flying rather than taking a train. So today, this is my experience for the last 40 years. Upon my journey, throughout my journey, I was in the machining. Completely machining before I was in die and mold industry. But 20 years ago, I thought that do valuable machining. So I do machining. I have done several machining, die and mold, 60 HRC in 1995 when the hard milling, 60 HRC direct milling, many of the companies, die and mold companies, they dropped the ice on the floor. In 2000, cutting 65 HRC is nothing because over the period of time, everybody learned how to cut hard material, direct milling, eliminate EDM, eliminate wire cut, eliminate polishing. This was, the initial is tough, it's difficult to adjust, difficult to accept, but have no choice. We have to move forward. We have to follow the technology. Then we can run the business forever. Okay. Why aerospace? That's the reason. It's growing, 200% growing everywhere. You know that in India is the largest, you know, we give an order to Boeing, Indigo. Air India, Tata, they're going to place 350 aircrafts. Nobody in the world, even China, no. We are going to place every week, Boeing or Airbus must supply minimum 2 aircraft per week. So that we have a lot of opportunity. India is growing the GDP. You know, everybody looking for. So we are going to be a second largest economy in the world. They say the 2040 or 2030. But are we ready for this aerospace industry? Everybody thinking that the aerospace industry can run only by the giant like Tata Aerospace, Mahindra, Wipro, HAL, then we're the small players. We are afraid because we are comfortable milling, comfortable machining. We are comfortable with those who have a CNC machine. Most of the people know getting 400 rupees per hour is how much difficult it is in India. But we are spending a lot of money. We buy a CNC machine in dollars or euros, 20% we pay custom duty. We are most expensive machine we are buying, but how much we are getting per hour is very cheap. But the same machine, cheaper in United States, cheaper in China, cheaper in Singapore, anywhere in the world, we are buying the highest cost, but the customer getting the lowest cost for the manufacturing. So we need to value-added machining. That's what we need aerospace. We need another vertical, die and mold, automobile industries we have been doing for the last 60, 70 years. Basically, the world knows India is automobile country. Is agriculture or automobile? It's enough. We have enough experience. We have seen the last 2 days. We have seen our people, our expert is excellent ideas. The excellent speech is all innovative ideas. So we are in the die and mold. We are competing China. But honestly, I'm telling you, we no need to compare with China. Because in China, I have been traveled 20 years. You know, my colleagues are from Makino, Japan, they know me. I stationed 5 years in China. Year 1995 is 2000, up to 2020, I travel every week every month I spend. I've seen government giving the money, government giving the place, government giving free everything. They were comfortable. Whether they make money or no make money, they no need to answer. Because all the companies started in 1995, all state-oriented companies. State-oriented company means you want to do business, the state people will come, they fund you, they ask you to do business. So such a way, I'm telling you honestly, I have seen more than 1 lakh companies. The small company, what they say, they have 100 machine, they have 200 machine. You know, Mr. Yamamoto-san, they enjoy, we enjoy. In Foxconn, started in 2000, you know, they buy Makino machine, 200 machine, buy molds, but we don't have a luxury because they manufacture for the world. They manufacture for the global, so that they buy thousands of machine. They have the technical institute. The technical institute, they train the engineers in the institute, not in the workshop. When any engineer, any ITI people come from China, the school, next day, they're ready to operate CNC machine, they're ready to work on CAD/CAM system, whatever the other subjects. They're ready. They prepare for the industry. But here, even how many? 70% of the engineers in India, they are in the IT field or in the call center, is away from this industry. Because it's a big problem. Practical oriented training is not in the institute. That means we need to develop this one. Okay. For example, when you start, for example, die and mold customer, automobile production manufacturing, we need to start because we are good in machining. Absolutely, we are good in machining. For the last 20, 30 years, we learned machining. We have a great machining people. I have seen, and I have visited more than 30, 40 countries where regularly I'm visiting. Last 40 years, I am away from this country. Just last 3 years, I'm back to India. You visit United States, you visit Singapore, you visit Malaysia, you visit Canada, every machine shop, you can find more Indian engineers. Anywhere you can see, you can find Indian engineers. As a machinist, as a programmer, why we cannot do this? Absolutely, we can do this. We need more training. This certification, you want to start an aerospace industry, no need to think big. Before start an aerospace industry, the certification is very important. How to prepare the certification? Honestly, I'm telling you, this 25 minutes is only to make how to make certification is not sufficient. So anybody want to know more about this after this session, anytime you can contact me. Okay, just I topic, I touch, I move. But you can see then the challenges in the aerospace industries, the tolerance is very tight tolerance, stringent tolerance, and material is difficult to cut. You cut 60 HRC and die and mold is a chicken, cut like a butter. But the exotic material like titanium, Inconel, and alloy aluminum is difficult. It's a tough material. It's not the hard material. We have a great solution for hard material, but tough material, heat, produce lot of heat while do machining. So exotic material and also complex shape. Shape is complex. You see, is 360 degree, you need to work out. The simple 3-axis machine doesn't help. Simple 3-axis machine doesn't help. You need more than 20, 30 settings in order to do multiple attacks, but you won't get the accuracy. Single setup, maximum 2 setups. So what kind of machine we need to enter into the aerospace industries? You need a minimum 5-axis machine. Without 5-axis machine, it's very difficult. But people thinking, oh, 5-axis machine, oh, head tilting, hand tilting, everything. No, it's very simple. When you learn within a week, 5-axis machining center is nothing. It's like a, like a human finger, hand, how you move around. It's one single setup. You need to complete the job in any kind of aerospace industry. I'm telling you honestly, this OEM, the aerospace industry, that means Boeing, Airbus, McDonnell Douglas, or the defense, okay, Lockheed Martin, these all the people, giant people, they make aircraft, but they are clever. They don't send any simple job out of United States. I've seen. I worked more than 3 years in United States. I've seen in the workshop. Very simple job. Just push the button, the job can be completed. They don't send any simple job to Asia. Please. It's more complicated job. It takes more human intervention. I need more R&D, need more fixture. They send out here. Because why should they send the easy job to outside their country? It's a common. So that means if we start to do this kind of job, I'm telling you, we can conquer the machining. They didn't do. I'm honestly tell you, we people, 12 hours, 16 hours I've seen in Indians. In the workshop, we're ready to spend time. We work on Saturdays. We work on Sundays. You can go to Europe. You can do Friday, 12 o'clock. Bye-bye. See you Monday morning. So please, we have a talent. We have an attitude. But the problem is facility. It's called an infrastructure. Then where to learn, how to learn, to whom I check. This is the problem here. It's not the problem. But we need more our association. The government had to support this industry. Is all SMEs. Today, my presentation, not for Tata, not for big companies HL. Today, my presentation, especially for small and medium companies, how to start aerospace machining. Okay, is no need to worry. These all the difficulties. Yes, machining is difficulty, material is tougher, all deep cavity, everything thinner, components are lighter, all the difficulties. Yes, we know. You say this is all just I'm showing this one, but I explained everything. I explained. It's difficult, of course difficult. If it's easy, American or European, even Japanese don't send the job here. They do themselves. Why they send here? Okay, how is possible? It's called scientific approach. Machining is not just tight it on the wires, take the milling cutter or drilling, just milling and facing. All time has gone. Automobile industries, you know, maximum facing, drilling, boring, reaming, that's it. What is the other more complicated? Tell me, guys. But 75% of the workshop I have seen, they're ready to do facing, drilling, tapping. That's all. Where is the technology? Then the people, 400 rupees per hour, the same people, purchase people come. 300? Sir, I'm ready to do next workshop. Why? There is no skill in the job. They're ready to, in Chennai, I have seen 250 rupees per hour crying and doing. Crying and doing how to make money. You say any business doesn't make money, no help. It's not, call it as a business. No need to do the job. Business means make money. Business means make money. Only when you make money, only we can say, oh, our company performing. So we need to do value-added job, value-added job. Complicated job is complicated. We don't want an easy job anymore for the last 60 years. Drilling, boring, all boring. Okay. So when you do the aerospace components, I'm telling you, this is a gear train. You cannot escape. I don't want to do this. No, you cannot escape. You need to take all the 6 tablets in order to cure. It's all binding. Machining strategy, CAD-CAM. You see the CAD model. When you receive the model from the OEM or receive the model from the customer, people take the model, directly start machining. No. You have to prepare the CAD model in order to match the CAM. You need to do expand, setup by setup, setup 1, setup 2. You have to prepare, cut the model, extend the model, make it outer, make the model for machining. CAD/CAM system, the strategies. You have to choose the right CAD/CAM system. Is the strategies user-friendly, that call, even in the CAD/CAM system itself, I can speak 5 hours. I have done several die and mold seminars. How to prepare the CAD, what kind of CAD features to, without breaking a tool, to run 20 hours, a single tool, how to run 10 hours, 15 hours on 58 HRC material. We have done it, we have proved it, but today, that means tooling is important, CAD/CAM is important, especially for fixturing. This is completely teamwork. Drilling and boring, one person, setter and programmer. I have seen in the workshop, one guy do the setting, manual programming, they run the job. That era gone. When I do aerospace machining, you need 6 people. These 6 people who are good in fixturing, who are good in machining strategy, who is good in machine setup, you need. Because he is a talent people pool, joined together and to work, dedication. They love machining. They love the job. They love the machining, only achievable. It's not come for monthly salary, after finish, run away, no. Every engineer in this country, for the next 10 years, who are involved in the machining, have to take the bus. In India, called the bus. We have to work it. We have to find out the solution until we reach the good result, that expected result. So how to overcome? Oh, madam, 5 or 50 minutes, ma'am? Oh, okay. I told this guy before call me, when I start this subject, aerospace subject, flight can fly, my presentation must be slow. Correct. Okay. So, I'm telling you, main components, you see, no need to worry about this, all machining. Major components in aerospace. Fuselage, you can see is a structure. This is a main structure. The structure is made of aluminum, and the binding, the cross-section is made of titanium. And the outside structure is carbon fiber. Nowadays, it's a carbon fiber. Before, it was aluminum sheets. Because now, everywhere, lighter, thinner, 10 different assembly or 10, 20 different assembly parts make it single parts. This is a challenge. We don't want to waste time for assembly. Multiple component, assembly, wasting time, losing accuracy. So that the concept now in aerospace, just now people talking about Giga and Mega, Tesla, one single complete car die casting. But aerospace is. But unfortunately, aerospace, any component, no casting, no EDM, no wire cut, no polishing, no manual polishing. Please understand. No wire cut, no EDM, no manual polishing, no die casting. Everything take from the solid block. Everything from the solid block. They don't allow. That's the challenges. See, that is a fuselage, engine casing. This is completely made of titanium. Completely made of titanium, but slimmer, thinner, but two-piece construction. You can see it's a 2-half bolted. That means too big raw material is remove the material completely, not the casting. I have to bolt it out. Because when you open the engine, top side you have to open, you have to do repair and assembly. This is, okay, next is landing gear. Fuselage, engine, landing, this is important. You know how many ton? Is 100 ton or 200 ton? From 800 kilometer speed, when you're landing, be safe landing, all made of titanium. This is very, very important. It's by milling, by turning, landing gears. It's completely made of titanium. Okay, next, jet engine. This is all the front is turbine. You know, it's a complete jet engine. It's made of, this is heart and brain. It's a power. This is very important. You know why this is very important? It's a completely impellers. The big impellers, they make single blades and they insert almost 20 rows, almost 20 rows. This is housing. They make single blade, they insert it. You see, when the flight take off from the Middle East, you know how much the temperature? 46 degrees, sometimes 52-degree temperature. 50 above temperature. When after takeoff, within less than 5 minutes, they reach minus 35-degree temperature. You know what is the variation? Within 5 minutes, plus 45, minus 30, 75-degree variation. That means what happened? Everybody knows we studied coefficient of linear expansion. Coefficient of linear expansion in any solid, gas, or liquid. By heat, it expands. We studied during our school, high school. Solid, liquid, gas expands when influenced by the heat. But they never taught that. Also, when you go to minus 30 degree, is also sink. It's also sink. We always think expand. But here is expand. When I go 50 degree, minus 20 degree temperatures, is everything start to sink. What will happen? Everything will shut off. We cannot stop the flight in the middle of the air and repair. Please understand. We cannot stop over there and do any repair. That is what 100%, more than 200%, the tolerance, the quality, no compromise at all. Because 800 people, 8,000 families. Please understand. No thinking of second thought. No thinking of second thought. More than 200%. Our side, I have seen in the workshop many times. My operator comes, sir, 10 micron oversize. Then the supervisor see the job 10 times. You make 10, every time you make oversize. Okay, next time don't do. Sir, this kind of attitude cannot. This kind of attitude cannot. Even I have seen, I work with, you say Japanese, I work for Makino. Almost I worked 10 years in Makino, Singapore as a technical application manager. I learned from them. You see, in the operator level, the tolerance is plus minus 5 micron. Even the operator knows is already exceeded 3 micron. Even they know they don't bring the job to the supervisor. Go to the grinding machine, grind it, throw into the dustbin. Please understand, this is a culture. This is a culture, machining culture. That means no, anything in the drawing as per the drawing. Anything minus or please don't show to the supervisor because our supervisor had to answer to the boss. So he 10 times flip, sure he will say okay. Please, this kind of attitude is not possible. Second, carbon fiber machining. In the front, the big fan is made of carbon fiber because carbon fiber is lesser, strength is higher. It can run at more than 20,000 RPM. So that the concept, lighter, thinner, compact. So these are all the major parts. So I will show you one example. I'm telling you honestly, you don't need to worry. You do some 10 exercise before you want to enter into the aerospace industry. I will give you some job. Invest money. You just invest money. Whenever you're free, call your operator, call your programmer. Hey, do this. If you do this, if you are capable, think of go get a certification. Then later, go and check the job. See, this is one of the example. You see, this is the under the wing. We call it as flat track beam. Before, 125 different parts. 125 different parts to assemble together. Today is one single piece, almost 2.5 meter, half a meter. I'm telling you, it's thinner, deeper, longer, and you see the solid block. 85% of the material, most of the time 90. Luckily, this time only 85% removed. I'm telling you honestly. But I have seen our cutting tool people, come with the big tooling. I have a power cutting. They say, I have a power cutting. My cutter can MRR, metal removal rate. All the magic they do, they fly to America without any shipping. I'm telling you honestly, this kind of joke works. It works only on certain areas, not on all the components. Certain components where you have a rigidity, you can do power cutting, you talk about MRR, but here, absolutely no MRR. Why? The major influence, distortion. After you cut, you just do roughing, you just place it there, go to tea break or lunch break, come back and see the job is become a boat. It's become a boat. Many people say, sir, when I cutting, it was straight. Yes, it was straight, but you stress. When you cutting load, you stress the job, you are unable to take the stress, the flat become boat. So please understand, this is the difficulties. Any component you do machining, think of distortion, think of stress. You cannot put into the oven to stress it, it will burn. You cannot do any stress relieving. So, see please, is a video? Boss, where is the video, boss? These guys also interested in my presentation. Please. Okay. I show you what kind of machine. Why I show this one? Because, sorry guys, tooling guys, because I pick up one video today morning after yesterday 11 o'clock I left because of some guys. So I pick up this video. So it's not for any promotion or something. You see, the selection of cutting tool, selection of machine tool is very important. Why I show this? Selection of cutting tool, selection of machine tool in order to do the job. What kind of job? You can see. This is what crocodile machining. Please. When he went inside, all the chip inside. When he went inside, all the chips are inside. Stop, sir. Stop, sir. You see, I know crocodile machining last 15 years. High MRR, metal removal rate is higher. 6 flute cutter. I can run, round, throw the material. But if I use the vertical machining center, because of the gravity, all the chip goes inside, is stuck, and the machined chip, again and again engage with the cutting tool, it damages the tool, it's gone. So this is what, when you do this job, you have to choose what kind of tool, not only what kind of tool, what kind of machine tool. Please, sir, next video. Ma'am, this is important, ma'am. All the way I come from Singapore. I told these guys, too expensive. Yes. No, don't this video. The next video. Boss. Yes, next video. Podunga. 174 HP cutting. No, no stress. Why? Same concept, trochoidal. No heat, no stress, no bending, because no chip accumulate inside the workpiece. Sir, next. Okay. So it's very important that everybody buy one VMC. Sir, I want to do aircraft job, aerospace job. So I told them, please, what the jobs I have shown is all the major aircraft job. That's all. Don't think of impeller. Everybody, they show impeller. I'm telling you honestly, you won't get the impeller. You won't get the impeller. Any 5-axis people sell machine, tell them very clearly, sir, don't cut impeller. Because American don't send impeller here. Understand? That is the easiest job on 5-axis. Easiest job on a 5-axis is impeller. But only we see, dancing like Prabhudeva. That's all. No much. I'm telling you honestly. No much. Impeller, forget it. But try to do multi-side machining. You can see the job as single block. Just now I show. You see the multi-side machining, clamping only 5 millimeter, but the height is 400 millimeter. The height is 400 millimeter, the length is 2.5 millimeter, clamping only 5 millimeter. That means they selection the fixture. What kind of fixture in the holding of 5 millimeter to carry 174 horsepower of cutting without distortion? That is important. But you can see this is a job, but I do roughing. I haven't completed one side. I take the one cut here, one cut top, one cut side. That means little by all side I attack, so that the distortion won't get. Most of the people, what they do, open, put the cutter, make it thin, other side whole thing vibrate. Then they get the boat, free boat. You can see this one. Just why I show you this, no distortion, high metal removal, attacking from all sides, attacking subsequently, not complete one side, little. Also, for example, not 5 millimeter all side, no. For example, this side, 200 mm depth, but on top, only 50 mm. I don't cut 5 mm here, 5 mm here. No. I use ratio cutting. If it's 200 mm, I cut 10 millimeter. Over there, I cut 1 millimeter. So that I keep the distance, I keep the wall thickness evenly. Okay, you can see this. It's almost 320 millimeter deep, but the corner radius 10 mm. Corner radius 10 mm. 350 meter deep. You know that I cannot use more than 20 dia cutter. But I use 20 dia cutter with 300 L by D ratio close to 15 times. 15 times. Okay. What is important? Before I take the long cutter, I know, because we studied physics. They said, call us a deflection. Any tool longer, what you will get? Deflect. When you cutting force act, deflect more. Pushing the material, deflecting, vibration, chattering, everything, all chattering, vibration, bring it to the skin doctor, put an injection. Correct. You see, you have to understand the deflection first. If you don't know the cutter going to deflect, because your L by D ratio bigger. If it's shorter, you can see this. This is the formula, how to understand, how to work out, how to minimize, split it into 2 times, 5 times, 10 times, 20 times, same kind of diameter, different kind of length, attacking. Yes, sir. What? Time up. Ma'am, till 2. I will rush, ma'am, please. For you, it's a different subject. You guys want to go home. But this is important. Last 2 days, these guys spend a lot of money. Okay, boss, finish. Okay. Sir, you can see this. Same diameter, different length. I use for one packet opening, 2 different. Just for this, boss, I little bit move faster. This is all understand. This time, how many times the deflection? Diameter same, but 2 times of the length, it deflect 8 times. Please understand. This is a scientific, is a mathematics formula. If the length is same, diameter is off, 16 times deflection. You see. So that you have to understand when you're using the long tools. Madam, another 2 minutes is there, ma'am. Okay. I show our tradition, show us. When I was small, I say, wow, every time, how to cut the deep cavity. I take the tool, open out the packet, roughing, semi-finishing, everything finished, is said packet. But after attack other side, do finishing, start vibration. Then I see this temple tower. You see the temple tower? Temple pole. This is called, when you have a deep cavity, when you have a slim wall, cut like a temple tower. You get the bottom is a support, slowly, then it won't vibrate. It won't vibrate during roughing. Even your model is straight, but you have to create a model like a temple tower. Okay, same cavity is a temple pole. So tool deflection I explained. Then the fixture. After I open up the packet, I need a support. You see the bottom support? This is the component. Bottom clamping, top clamping, not only mechanical, also vacuum clamping. Then how to measure? This is the measurement, like a air, no clamping force, because the flatless less than 0.2 millimeter. The job like this, every time is a aircraft top deck, bottom deck. Titanium machining. You can do how we attack, solid block, just clamping, we cut, keep some material, after finishing, only the holding. Okay, in aerospace component machining, you use any tool or any drill. You must use the tool to find out how much accuracy we can get it, what is the tool. This is called as a tool validation. You cannot any tool and use it, no possible. You can see, I use just only drilling and reaming. I spend more than 5 days, more than 50 plates, take the tool, cut and try. I find out the complete father, mother of the history of the tool. Whole history of the tool. So you can see, go. Okay, over here, no go entered. That means this is a titanium material, that is the aluminum material, same tool, same, but here, go is fine, no go. So rejected. So something like this validation is important. Next, all these aerospace industries, you guys need a training. For your good information, I was the trainer of world skill competition. I don't know how many people know. For CNC machining, there is a competition in the world, like an Olympic, every 4 years Olympic. Same, the call as a machining Olympic. 2 years one time, Tokyo, London, Germany, I was the trainer. You can see, this is kind of component. I train my people. I train my engineers. When I join, the engineers join me, I give this exercise, throw only the drawing, is complete machining they do. You can see this world skill. These all the components for the world skill. Okay. So my job all the time, I travel, give the training. These 2 students, when I was in United Kingdom, I was appointed to train these 2 guys to, compete in the world skill competition. I trained these 2 guys 3 months. They won the silver medal. These guys won the silver medal. This is where the training is important. See, this is the world skill training. Training. Without training, nothing can happen in aerospace. So next, All these things I'm doing. You need some mentor. When I was when I moved to Singapore from Bangalore, I met this man. I never met this man before. He saw me in the workshop. He called me, Mohan, why don't you come and join in the machine tool company? I was a good machinist. I was a good programmer, but I was not in the machine tool. But this man saw me. He pulled me. He put in Makino, Singapore. He was a manager, application manager, Mr. Shankaran. I was a student. He was my mentor. He gave an opportunity, asked me to travel. He sent me more than 45 countries. I visited the great nation in the United States mold shop. At the same time, in Africa, the mold shop in the hut. He sent me around the world, around the global, to go teach them, train them. This man given me opportunity. So I learned this skill because of the mentor. So all the thanks to my boss. Unfortunately, he passed away last year. So this is all the credit. Such kind of mentor you need. You need to find a mentor. You need to train yourself, push yourself. Every day in front of the machine, drink 2-liter petrol, you get fire. Okay, thank you very much, guys. Thank you for giving the opportunity. Thank you very much.
Wonderful, wonderful.
Thank you very much.